So you guys all got my email about how all these are being videotaped, and then I'm going to post those. I said that already, didn't I? I think I said that already. Okay, good. All right. So frequency distribution is when you organize your raw data into table form using classes and frequencies. You can use a tally if you want. Tally is just the frequency in tally form versus numerical form. It's just a step you might want if your data is kind of harder to keep track of. So I'm going to kind of go through. I want somebody, go ahead and read me the numbers. Read me out the numbers.
0, 0, 2, 3, 7.
Okay.
8, 6, 3, 2, 3, 1, 2, 1, 2, 3, 4, 13, 2, or 3, 1, 1, 5, 1, 8, 4, 1.
Speed that up, pause it. 1,
1, 1, 1, 6, 2, 4, 1, 2, 0.
Great. Okay, so we have 3, 10, 7, 5, 3, 1, 1, 1, 1, and 1. Okay, so how many classes are there? How many classes are there? How many classes do we have?
9.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Someone might say claim 10. Can you guys say 13 down there? There's a 13 there. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 13. Someone might say 10. Would you believe me if I said that they are 14 classes?
Yeah.
Here's the thing. We go 0, 1, 2, 3, 4, 5, 6, 7, 8, and then we jump to 13. So really, there's also a class for 9, 10, 11, and 12, all with 0 in them. Do you see what I'm saying? So really, this would be 14 classes. Okay? Good. Okay. Just make sure you guys kind of understand that. You can't have gaps like that in there. Let me ask this question. What if it's impractical to have each value have its own line? So think about how many days a year do you drink coffee? And I don't mean like how many times do you drink coffee? Because you could drink it 5 times in a day, and that would still count as that one day, right? But like some people drink, like I drink coffee like 3 days a year. And whenever I'm like really tired and there's no other option around and I just need caffeine. Other people drink it every single day, 365 days a year. And maybe they take off one day or something like that. So how many days a year? So the lowest you can be is 0, none. What's the highest you can be? 365. We're going to assume a non-leap year. So I have 365 plus 0, 366 possibilities. I can't put 366 different classes out there. That's ridiculous. But I have all this data. So in other words, I have some people who said 0, 3, 10, 365, 365, 200, 150, 12, 365. I have all this data. How can I show that data effectively? How can you show that data effectively? So why don't you talk to your neighbors and see if you can find a way of showing that. Think of possibilities.
That's why I didn't look up and I realized what we were counting.
All right, so who has an idea? Yeah.
By using frequency table,
Uh-huh.
suppose one person is drinking coffee 5 days a year.
Mhm.
Another 5 people are also drinking coffee 5 days a year. So by putting value 5 in front of that frequency or repetition of 5 for 6 times. So we can compact the data by using frequency table.
True, but I would have 365 options though. That's a lot of options. So definitely we can take a raw data and put it into a table, and that would definitely make it clearer and more compact. But I don't want to have 365 different options there. Did you have an idea?
You divide them into groups.
So-
Like same intervals. So like let's say you do 30, 30, 30. So
Mhm.
it's sort of 30 days a year and then 30 to 60.
Does that make sense? So she's saying go like from 0 to up to 30, up maybe to 29, and then 30 to maybe like 59, and then like 60 to 89. That's kind of what is that what you're thinking? Or do you have another idea?
Me?
Yeah.
Mine would probably be impractical too, but I just did like take like the average of like, say like the first day of every month and take the average of that.
Oh, you're saying, yeah. Well, the problem is you don't know because you already got this data from people. It's already done. You have this survey. You already have these numbers. 5, 30, 365, 12. So, right? So, or are you saying divide by 12 and kind of get an average per month?
Yeah.
And then make them smaller numbers? Right. I see what you're saying. So you kind of would just adjust them down, which in a sense is sort of grouping them kind of in a way. So what we do is group them, you're saying. So we put them into groups and make what we call the group frequency distribution. So here classes are grouped. So here it's grouped 0 to 60, 61 to 121, 122 to 182. So there are 6 different groups you can fall into. So let's go ahead and go through it. Everybody tell me. I'm just going to put it straight to the tally. I'm going to try that. So everybody tell me, we're going to do the same thing, only tell me how many days a year. So 365 days a year, that's your maximum. How many of those days, I don't care how many times in that day you drink it, how many days out of the year you drink coffee. Okay, ready, set, go.
364.
Uh-huh.
365.
Uh-huh.
200.
Okay.
250.
Uh-huh.
67.
You know what, I should write this down. I just realized something. Hold on, I'm going to do that. So we had 365, 364, 250, 200. Okay, keep going. What did you say, 64?
67.
67. Great, next.
330.
30, next.
10.
10, next.
0.
Next.
365.
Next.
0.
Next. Next.
0.
Next.
0.
Next.
365.
Next. Next. Who's next? Next.
0.
Next.
15.
50, 5 0?
1 5.
Or 1 5?
Yes.
Next.
275.
275. Next.
250.
Next.
50.
Next.
150.
Next. 30. Next.
250.
250. Next.
24.
24.
Yeah.
Next. Next.
365.
265.
365.
365. Next. 250. Is that right? Next.
365.
Next.
200.
Next.
0.
Next.
100.
Next.
0.
Next. 30. Next.
281.
281. Next.
180.
180. Next.
0.
0. Okay. Good. So one thing that I want to comment on is that largely people kind of went with round numbers, right? You'll notice that when people self-report, like if they self-report their weight or they self-report other things, they tend to like round them to the nearest 5 or something like that. Or like with you guys with really big numbers, you'll round it to the nearest 25. So that kind of happens a lot with self-reporting. Like if you actually evaluated and someone watched you every day to see if you drank coffee, probably wouldn't be exactly 250, right? It'd be like, maybe 257 or something like that. So that's one of the things that's interesting about when people self-report. All right, so let's go ahead and go ahead and write these in. So if you were here, 67. Let me get someone to start me off with 67 and tell me what's next. Do the same thing.
330.
330, great. Next.
10.
Next.
0.
Uh-huh.
365.
Yeah.
0.
Yeah.
0.
Yeah.
0.
Mm-hmm.
0.
Faster.
365.
Next.
0.
Yeah.
15.
Mm-hmm.
375.
Mm-hmm.
250.
Mm-hmm.
50.
Mm-hmm.
150.
Mm-hmm.
30.
Mm-hmm.
250.
Mm-hmm.
24.
Mm-hmm.
20. 365. 250. 365. 200. 0. 100. 0. 30. 281. 180. 0.
Is that? Okay, good. 16, 2, 2, 2, wow. 6, 7. All right, good. A nice, good, decent spread. All right. Also, we often find useful to look at the percent of the total that each group represents. We call it the relative frequency. It shows how data is related to the total, because a lot of times when we're comparing sample sizes that are different sizes, that are drastically different, it's really hard to compare, these hundreds of things to like these smaller numbers. So if you look at the percentage each one, then you can kind of compare percentages, and it's a lot easier to compare them. I'll show you a slide on that later. How do you find this? You find the total frequency altogether, and then you find the fraction that each class is of the whole. So I'll show you what I mean. So here we have 16, a bunch of 2s, and a 6, 7. (16, 2, 2, 2, 6, 7). Oh, whoops. 16, 2, 2, 2, 6, 7. All right, so all together we had how many? Looks like 40, 33? 30, 35, 35. Okay, so all together we had 35 people. The first class, this first group, they have 16 out of 35. However, they don't express these as fractions. They always express them as decimals or percents. So let's do it as a percent. 16 out of 35. 16 divided by 35. 45.7%. 2 divided by 35. 5.7%. 5.7%. 5.7%. 17.1%. 20%. Okay. So pretty much we always express these as a decimal or as a percent. So as a decimal, this would be 0.2. I'll write them off as decimals off to the side, just so you guys can see that also. This would be 0.457, 0.057, 0.057, 0.057, 0.171, and 0.200. I guess you want to smooth it out. And you'll notice that if you added these up, it would only be like 99.9%. or 0.999. Why is that? Why doesn't it? We know that they're all there. You know what I'm saying? But because of rounding, we might be off by just like a fraction of a percent. Because of that, because there's some rounding error. We've rounded somewhere along the way. So we lose a little bit when we round. Okay. Is everybody all right with the idea of relative frequency? It's the percent of the whole that each category is. So this class here is 20% of the whole. It's 20% of the people are in that group. Here, 17.1% of the people are in this group. Okay? Here, 5.7% are in this group. And like I said, it's a lot easier to compare different samples using percents than it is using actual numbers, because they might be if they're different sample sizes. Oh, is it time to go?
No.
No.
If you want.
No. Oh, no. I'm sorry. I just don't remember this one. We did it. We totally did it. So nominal, ordinal levels, data encompassing categories. We also have categorical frequency distributions. Using categorical data. So here's one example. So this is the very first problem on your chapter 2.2 notes. Given a blood type to determine a blood test to determine their blood type. Conducting frequency distribution for this data, including your relative frequency. So I'll flash back up this so you can see what it sort of looks like. Right, either that or that. You can include the tally or not include the tally, I don't care, but you need to have your classes, right? What different possibilities you can have. And then you need to have your frequency. You can have a tally if you want. It's up to you. It's optional. This is just, these are the same thing. This is just it expressed as tally marks, and this is it expressed as a number. And then the relative frequency, either in decimal or percent, either one. Does anybody need chapter 2.2 notes? Everybody has them? 2.2 notes? Yeah, make one of these. Make a frequency distribution chart. Right in there, got some room there. Well, yours won't be called days you have coffee, it'll be called blood type. Exactly. Put it right next to where all the data is, just to the right of it.